Hey, Spartans. Hey, I wanted to create just a quick podcast for you. I hope this is helpful for you. There's kind of a couple of ways that you could use this. Maybe you were absent for class, or maybe I was absent because my wife is she's due coming up, so it could be that. Or it could simply be something where you're in class and people have a lot of questions that are going on. And so maybe this is something that maybe we walk through together through that, and maybe you're looking at that as well. So however you're using this, I hope this is beneficial for you. This is not the podcast review that we normally do online. However, it is a good way to go over a couple major questions, major concepts as it relates to what's on the test. All right, so let's get started. We're going to get started here with how I use my calculator on the rules of means and variance. Hopefully I printed these out for you. You could kind of find those. This is a little bit separate. That's there, so go ahead and find these there. So before I go to how to kind of plug this in, take out your calculators, and I want to make sure that you go to the stat edit. All right, so we're gonna kind of do some of these together here. I do just want to show this real fast. So yeah, you're gonna go to stat and then go to edit, and then if you're trying to clear a list, you can go up to L1 and then press down, although don't do what Hannah did. I think it was Hannah. She deleted a whole row, and I'm still trying to figure out how that happened, Hannah. But Hannah, I don't mean to call you out. I'm sorry. I know other people have done that too. But as we plug this in, what we have here, and I'll kind of get, where are you? Here we are. All right, so we're going to put -1, 0, 1, and 2 in for L1, and then we'll kind of plug in the probabilities that are there, okay? So we're going to go, there we have -1, 0, 1, and 2, okay? Remember the corresponding probabilities go with it, so 0.3, 0.1, 0.5, and 0.1 as well, okay? Now, once I get this, I can actually solve for the mean and standard deviation. Remember the expected mean, I would just multiply the value by the probability and then add them all up once I'm done with that. But I'm going to go to stat, calc, one variable statistics. Remember L1 is your list. Your frequency, normally we did where that's blank, right? Where there's actually nothing there. But let's say you're doing a probability distribution. You want to make sure L2 is put inside there. So you're going to put L2 in, press calculate, and there you are. You got your mean, which is 0.4, and 1.02 as your standard deviation of X, and your mu of X, that just means your mean of your the X variable would be 0.4, okay? So we're gonna put 0.4 here. I already did the other one down below, but you could do that if you were to, you had any questions on that, you could kind of combine those or try to see how you do it. Go ahead and attack that one as well, all right? The variance would be simply the standard deviation squared. So you could just take the standard deviation of Y and square it, the standard deviation of X and square it, and I'll do those right here. That way I've got it right on my phone calculator, Michael. Hopefully, if you do not have like a TI on your phone, you need to do it. The cool kids are doing it now. I'm telling you. You got to be yeasting. Yeah, I went there. Sorry about that. I apologize. I can't help myself sometimes. 8409. All right, Eric, thanks for your help there, by the way. So what we've got here is we've got the values up on top and the values down below for the mean, variance, and then standard deviation. Let's talk about this real quick when we talk about combining and attacking this here. This says number 3, what is 3 plus 2x? So if I was to take all of these variables and multiply them by 2, add 3, this would be -2 plus 3 is 1, right? These probabilities would stay the same, right? They would stay the same when you did them across here, okay? So you would just take these, multiply them, and go. The big thing is what happens with the mean. Well, a mean changes on everything. I don't want to say, well, no, I will. Everything. Variance and standard deviations are a little bit different, okay? Those only change for multiplication and division, okay? So if I were to, in this example, take the top illustration, and I were to say, okay, the mean is 0.4, what would happen if I multiplied all the values by 2 and then added 3? It would do exactly that. So 2 plus 0.4 is, and then I would add 3. It's literally it. So 0.8 times, or plus 3 is 3.8, which is my mean. My variance and standard deviation, we could look at that. Well, remember with standard deviation, the 3 does not affect standard deviation, right? And by the way, if I plug this in, it would show these values from up here. I'm just trying to see how this happens. So multiplication and division, when plugged in, and I'll plug it in the exact same way, 1.02, this would not impact it because remember, adding and subtracting does not change variance and standard deviation. Same thing holds true for what's up here, okay? So 2 times 1.02, this is my standard deviation here, my sigma, is 2.04, okay? So that's my standard deviation of my W, okay? This was mu of W because that's my new variable, okay? Now, down below, let's look at our, what happens with my variance when I multiply by C? Well, remember that the squared actually goes to both parts. That's a little different. So C is squared, and so is obviously the standard deviation, okay? So if I were to do this part, really, I could just square this down below, or I could square each part. So I could just say C is the 2, so we'd say 2 squared times 1.04 squared. I'm sorry, 1.02 squared, because that's a standard deviation. And when I do that, I could do 4 times 1.02 squared, and that would be, I think, a 4.16. By the way, I could also multiply this and just square this to get the same answer. I just want you to see that I can't just multiply by the variance by 2 to get to that 4.16. But if I multiplied it, found the new standard deviation, then squared it, I could do that, which would be the same thing I did down below. Now, here's where it becomes a little tricky, and where you just want to kind of look at, hey, how do I solve this? And these are the two that I want to look at. So when I add x plus y, what happens is all these values have possibilities, right? So 2 plus -1 is 1, 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, right? I'd have to do that for all of them. So if I did this, it'd be 1, 2, 3, 4, right? The other possibility, because 2 goes to each, right? Now 3 goes to each. So then it's going to be, all right, well, then it's going to be 2, 3, 4, 5, right? And then the next one is 3, 4, 5, 6 when I combine them together. Now, when I do that, notice that if I have 2, let's say 2 to -1, to get the probability of 2 or -1 plus 2, I'd say 0.3 times 0.6, right? 0.3 times 0.6. And you fill out all of these by just simply multiplying them, right? So come into another one, 0, 2, so that'd be 0.1 times 0.6. So this would be 0.06, this one would be 0.18, and I would just find all those probabilities here. Now, I could do that, plug it into my calculator, and find the standard deviation from what was on 4A. However, what I know about this is if I add 2 means together from 2 probability distributions, for the mean, I can say mu of x plus mu of y equals mu of w, based on this up here. The standard deviation works similar, or does not work similar, because I know that the standard deviation of sigma x plus sigma y is not equal to the sigma of w, because one cannot, everybody show it up, Yes, one cannot simply add standard deviations, right? Okay. All right. So because of that, what we got to do here is we got to come in here and say, okay, what is equal? Well, what is equal is when these things are squared. So the variance of W of the variance of W is equal to the variance of these two added together. So if I added, let's do the mean first, 0.4 plus 2.6. This would be 3.0, okay? The variance, a little bit different, 1.04 plus 0.8409. Is it 1.04? And 0.84 equals the new variance. So this would be 1.88, okay? However, remember, if I were to find the standard deviation, I've got to square root this, right? So my last one, and this is the tricky one, is the new standard deviation of W is equal to the standard deviation of X squared plus the standard deviation of Y squared, and that equals the new one. So here we go. And by the way, the square root can't go to both parts. Algebra 101 kind of helps us with that, is that it can't go to both parts when they're adding and subtracting. So you have 1.02 squared plus, sorry, let me go back here, 0.917 squared, and then I would go from there, and that's how I would find the new standard deviation. Notice down here for B, or for 5A, when it's X minus Y, everything will be the same. So this would be the same. This would be the same whether it's adding or subtracting. So same formula, no difference in adding or subtracting up here, even though I know I'm subtracting here. However, the only difference is we subtract the means to get the new W here. So it'd be 0.4 minus 2.6. That would be the only difference on that one. All right, now take the next thing, the finding the cherry starburst. Try this out amongst each other. Talk about, is it a binomial distribution, right? The number of cherry flavor starburst candies in the bag. Notice this is not independent, okay? However, what condition, this was on our last, was on 6.3C, so if you need to go back, what condition, even though it's not independent, if it's large enough, right, to where the 1/10 of the population is greater than the sample, then we can assume independence. It's so big that independence wouldn't even matter in that instance. So make sure you show that if that's true. This is called the 10% condition, okay? 10% condition. What is NP? Okay, goes through this. What is the mean? If it's binomial, remember the formula for both of these. That's important. Know where to find it on your formula sheet. Probability of getting exactly 60. So this is the probability, just a heads up, of X equaling exactly 60, right? What is the probability of getting at most 60? So this is the probability of X being less than or equal to 60. Notice PDF versus CDF, right? Okay, I'm hoping this is helpful for you. Redo this problem. Remember, I have to show this in order to use a normal distribution on a binomial. And we call this, when we use these two instances, we call this the law of the large conditions. Sorry, I was thinking pre-cal. Large conditions is something as well that you can use there. Okay. Cool. Again, I hope that was helpful for you. There is, oh no. Oh, I literally was talking the whole time. Doggone it. Okay, so, all right, here's the deal. We're going to, because this is live, I'm going to backtrack real quick. Okay. My apology, y'all. Let me backtrack real quick. I want you to see where we're at here. You were listening to me, but I know. I'm sorry. Oh, my apology. Okay, so here's the thing. I'm going to do this. I'm going to throw this up here, and we're just going to talk through it, okay? Cool. All right, so we were talking about the calculator stuff, right? Okay, so we went through this and this. Let me make sure I'm all good. Dadgummit. Sorry about that, y'all. What we know is that as we were, I had some funny comments too in that. If you skip this, I apologize. So as I look at this, this was from my calculator. This was this squared, right? From my calculator squared. All right, here's where I went. With me, whatever I do, 3 plus 2x is what I was saying from what's up here. This, whatever I plug in for mean will affect it. So 2 times the mean, 0.4 is 0.8, plus 3 is 3.8. For the variance and standard deviation, only multiplication and division affect it. So that means this 3 over here would not affect the standard deviation. And so I always find the new standard deviation first, and then I can always square it. So if I did 2 times 1.02, which was the old standard deviation, that would give me the new one. To get to variance, the new standard deviation I square to get me to 4.16, okay? So that's all I was looking at there. The one thing I wanted to highlight was when I add 2 variables together, the means, when added, will also be added, okay? That was easy. But with the variance actually both will be added too, and we found that that was 1.88. But remember, the standard deviation squared is variance. So if I were to square root both of these sides, is what I was showing y'all, then it would be the square root of the standard deviation squared of x plus the standard deviation squared of y. Inside parentheses, the square root cannot go to both. So therefore, I literally plug it in, and that's where when I add 2 different variables, one cannot, here we go, everybody, put it out there, one cannot simply add standard deviations. Good, and if you try, I will haunt you until the day is long, okay? All right, so that's how we do it. And if it's subtracted, these 2 actually are the same formula, no difference. Please don't change this to a negative if I subtract 2 variables. Same formula, the only difference, remember, whatever I see with mean, I put down, right? And that's how I attack it here. And then this would be the last part here on this one, is when I come back to this, I was just showing you non-independent. It's just giving you some highlights and hints. When I attack these here, the probability of x equaling 60 versus at most 60. So the difference between when I use CDF and PDF. And then also normal distributions, the large conditions means that this actually can be approximated as normal if it is true. And I show that, in fact, they are true there, okay? My apology on that. I hope that you could just kind of skip through, and hopefully that helped you out just a little bit if I'm not here. Be blessed, y'all, and we'll see y'all later. See y'all. Bye.